and I will start the problem number 49. So this is the average velocity of a body moving with uniform acceleration after traveling a distance of 3.06 meter of 3.06 meter is 0.34 meter per second. If the change in velocity of the body is 0.18 meter per second, then find its acceleration. So what is the average velocity of a body moving with a uniform acceleration after traveling a distance? That means it is moving in a straight line. Okay. So average velocity of body moving the uniform acceleration after traveling a distance of 3.06 meter. It is attaining a velocity. Let's say this is velocity is okay, and let's say the acceleration, uniform acceleration is a. There must be some initial velocity u. If the change in the velocity is this, so means v minus u change in velocity is 0.18. So it is very easy to get the u. The u is equal to the final velocity minus change in velocity. So that means that is equal to 0.34 minus 0.18. So that is equal to 0.16. That will be meter per second. Okay, so this is your initial velocity. Then find the acceleration. So acceleration is nothing but it is v is equal to u plus that means there is no time is given, so you have to use v square is equal to u square plus 2a and s distance. Distance is given, a have to calculate, u and v you know. So a is equal to v square minus u square by 2s. So v square is equal to this 0.034 whole square minus u square is equal to 0.016 whole square, that into 3.06. So if I calculate it, if I write it here, v square is equal to 0.34 square minus 0.16 square divided by 2 into 3.06. So that means this plus this, that is equal to 0.5, and this minus this is equal to 6.18. Okay, 6 is 0.78, 2 into 3.06, so 6, 3, 6, 5, 1, 3 is 17, so that means 0.5 into by 34. Okay, so that is around how much? That will be the acceleration anyhow. That is equal to 0.5. That everything is, this is in meter, this is meter square. Okay, so 0.5. So if we take it out 0, so that means equal to 534. It's almost 0.001 340 160 0, almost how much? 4 times 240. So almost this one approximately you can say. Then after it will move to 7, that means 0.015 meter per second square. So that will be the answer. Okay. Next to number 15, and that will be the end of the kinematics problem solving session. But this session will also move into the remaining part of the vector that we will explain. So this is 50 number. It says a body covers a distance of 4 meter in second and 12 meter in fifth second. If the motion is uniformly accelerated, how far it will travel, how far it will travel in 3 seconds. So the body covers the distance 4 meter in second, 12 meter in 5th second. So as per the Galileo's trick, we know that any distance traversed in particular time means at nth time vector, to say n minus 1 half into a. U is the initial velocity, a is the acceleration. A body covers a distance at the meter second. So for this and this is unknown. So there are two set of value. First set of value 4 meter second. So t n is equal to second. So n is equal to nth second here. This means the distance is 4, u unknown, plus u is the initial velocity, and a is the acceleration here. Okay, so this is Galileo's trick. N is the 2 minus half into a unknown, so that will give you 4 is equal to u plus 3 by 2 a. This is your first equation. So this I will write it on the top. This is 4 is equal to u plus 3 by 2a. Okay, 3 by 2a. The first equation. For the second equation, that is 12 meter, the same u will come plus 12 fifth second, so 5 minus half, that means equal to 9 by 2. 9 by 2 will be second equation. So from this you can solve it. So that will become 9 minus 2. If I deduct 2 minus 1, so this minus this is equal to 6 by 2, that means 3. 3a is equal to this minus this is equal to 8. So a is equal to 8 by 3. 9 minus 3 is equal to 6 by 2, 3a. And u is equal to 12 minus 9. You can use it here also. Use the lesser equation. So u is equal to 4 minus 3 by 2 into 8 by 3. So that is equal to 3 by 2 into 8 by 3. So 3, 3, 4. So u is equal to 0. So initial velocity is 0. Now I have to find unit of acceleration, how far it will travel. So now a you know 8 by 3. So from there the equation will be the distance is equal to u is equal to 0. So half into a, that means 8 by 3 into t square means 9. So 3, 3, 2, 4. So that means 12 meter. So this is the answer for this question. So this is the end of the problem solving session, and now I'll move into vector law of addition. Vector law of addition. So in this segment there are three laws. First law is addition law of triangle, addition polygon law of addition for vectors, and the parallelogram law of vectors for addition. So first one is triangular law of addition for vectors. So in this portion I will discuss about the triangular law, what is it mean. So if it says, if the two distinct vector in magnitude and direction represented by the two arms of a triangle in order. In order means whether it is clockwise or anti-clockwise. Both the vectors should be consecutively in same direction, either in clockwise or anti-clockwise in order. Then the third side which closing the triangle will represent the resultant of these vectors in magnitude and direction magnitude and direction in reverse order. So let me read it out. If the two distinct vectors in magnitude and direction represented by the two arms of a triangle in order, then the third side which closing the triangle will represent the resultant of these vectors in magnitude and direction in reverse order. So what does it mean? Let's say this is a triangle, and these two sides represent two vectors in order. That means if it is anti-clockwise, the consecutive vector has to be in anti-clockwise. Then the third side will represent the sum of this resultant of these vectors in reverse order. This means it is, you can say this is anti-clockwise, this is clockwise. In clockwise, the resultant of these vectors. So this is the triangle law of addition. This can be other way said. This is the first part of the definition or the law. You understand that it can be of also if it is this way around. So then in that case the resultant would be in the reverse order of the vectors taken in clockwise direction. So that will be anti-clockwise direction. Both are possible. Okay, in that case I can say, if you can say this is resultant, so the resultant equal to A plus B vector. Okay, this is first part of that. Second part is the same law can also be represented in other way around, or the second part is that if three vectors are acting on a point and the resultant is 0. So that means three vectors acting on a point A, B, C, let's say, acting on a point, and the resultant, that means vector A plus vector B plus vector C is equal to 0, then these vectors are represented by the arm of a triangle in magnitude and direction in an order. That means in this case three vectors are to be in same order. That means if I say this is a triangle and this is A, this is B, this is C, all the three are to be in same direction, then this implies that vector A plus vector B and vector C, sum of 3 is 0. That has to be represented by a triangle, and this could also be possible if the direction is also the reverse one. Vector A plus vector means this could be A again, B and C. So this is also possible if it is in reverse direction also. So in this case three vectors acting on a point, if the resultant of three vectors is 0, there is no residue vectors acting on any direction, then the vectors can be represented by the arm of a triangle in one order, in a order. So this is the triangular law. Okay, so this is the first law of the vectors, that is vector addition law. This is the rule for adding three vectors if they are following the condition that is described in the law. Okay, so in the next video I will describe other two law, that is the polygon law of vector addition and the parallelogram of vector addition, and some derivation on the basis of the laws. So this is the end of the chapter 29. In the next chapter 24 I will discuss the remaining, and followed by the few numerical problem on this vectors. So that will complete the total vector, and the kinematics already are completed. Then I will move to the some other subject or mathematics again. Okay, thank you.